Hello everyone, this is Jeremias Blendin from Intel. Today we have a P4 workshop talk from Venkat Pullela and Surendra Anubolu on the topic of Applets, a portability and composability solution for P4. Venkat Pullela has worked for 8 generations of switching pipelines as part of the Catalyst switching team at Cisco for more than 20 years. He also built Cisco's first P4 switch on Doppler using an internal language. Later, he was at Broadcom working on programmability architectures, including the NPL language. Furthermore, Venkat started OpenNets, a startup that built tools for the SDN space. Currently, he is at Keysight looking into testing of planet-scale infrastructure. The second speaker, Surendra Anubolu, is a distinguished engineer at Broadcom building Ethernet switches. Prior to Broadcom, Surendra was at Cisco driving the Doppler programmable pipeline architecture. And with that, I hand over to Venkat, and I'm looking forward to your talk.
Thank you, Jeremias. Happy to be here. It's a good workshop we had last year. We covered a couple of topics on intermediate representation. So this year, we're going to cover portability and composability aspects of P4. Again, this is a proposal. So before I get started, I want to introduce a couple of folks who worked on this and then they're not here. I'm Venkat Pullela from Keysight. Surendra is with me right now from Broadcom. Shyam Kaluve and Madhu Dhavala, both from OpenNets. They did quite a bit of the implementation work on the IDE tool that we'll talk about later. Sahil Gupta is our intern from RIT. Thank you. Thank you, all of you. And then let me get started. Okay, so this will be the agenda. We'll talk a little bit about what is modularity, portability, composability. And then we'll talk about applets and the specifics of the proposal. And then we'll talk about composability algorithms, which are, how do you merge multiple applets? And then we will get into a little bit of Q&A. So what is modularity, right? It's there's no new definition of it. This is, as you build software and hardware, I guess, when things grow beyond certain size, it helps to have building blocks so that you can scale and build bigger things, right? And in P4 as well as NPL as languages, we didn't have any explicit specification for modularity, right? But it doesn't mean they don't have. There are building blocks you can use. P4 has control blocks, where you can keep multiple tables and a little bit of functionality, and there is a control flow inside as apply and things like that. And NPL has something called functions, which are used both for logic as well as control flow of sorts, right? So there are some blocks that are already there in the language. And then typically, if you look at P4 programs, you will see that most of it is written, what is out there that we all have access to, right? In open source, we use hash includes, right? You keep your code in different files and you include them in the right order, and somehow we are getting by that, right? And even though you have modularity somehow, what is missing is something called composability, and we'll talk a little bit about it later, right? And then I somehow feel that some of this modularity is not adequate. It's okay. Even now, I think it is okay. But I'm seeing programs that are growing into tens of thousands of lines, right? I mean, I have seen, for example, 50,000 plus line programs, even a couple of years ago. So at that level, modularity using constructs that are in the language are not enough. So you may want to have bigger and bigger building blocks so that they can be put together, right? And then that kind of makes it easy. And the other thing about modularity, again, overlaps a little bit with composability is when you are writing one of these modules, what is the knowledge you need? Do you need to know about the whole system to be able to build one block? Or, or if you are an expert in certain parts, can you just focus on that? Right? So there are multiple dimensions to modularity, not just building the Lego blocks. So, and we will talk a little bit about all that, right? And portability is is important. There's quite a bit of work that happened, right? Early days, I think all of us wrote whatever we wrote. PSA helped a lot. It standardized one way of writing P4 code so that, there is a little more portability across architectures. As more and more ASIC-based implementation started coming out, right? Early day software is always easy. x86 architecture or C, or that is a little easier part. I think when we started seeing more and more ASICs that do P4, I think PSA helped, and we're still actively working on the PNA to see how it maps to even the NICs, right? So, but even though we have PSA, fundamentally pipelines, right? I mean, having worked on 3 or 4 such pipelines across the industry, each of the switching pipelines seems to have some foundational differences, right? And that's why you have seen multiple languages, like Jeremias mentioned, right? I worked on an internal language at Cisco. Broadcom has NPL, P4, and I'm sure there are some internal languages here and there. The hardware architecture below has some foundational differences. And while P4 described one programming model, and it may or may not map easily and optimally to other platforms, right? And then, so you cannot just let it write a code and just make it easily portable. So it's important to kind of talk about what are these differences and solve them, right? And it becomes more and more important because of the wider adoption of P4 now than before, right? It has become the de facto standard. So what are they? What is so different, right? Simple things like, can you modify the packet in the ingress pipeline or egress pipeline? And can you even modify the packet at all? Or you only keep metadata and modify only at the end of the pipeline? Is it something that you can abstract it out and then implement on any hardware? Maybe yes, but there are inefficiencies in that, right? I mean, if you're keeping all the metadata till the end of the egress pipeline, then your bus widths, right, that you need to carry through ingress to egress and even through the ingress itself start becoming costly. And there are other things like, how do you modify the packet, right? I mean, what is it do you recreate the packet, or do you have like a deparser, right? From a packet you got some metadata, and from metadata do you go back to the packet, or do you have something called an editor? That means you take the packet as is and you modify a little bit, right? These are different models as such. So programming models differ. So how do we deal with those things? And can we deal and can we solve those, right? And finally, composability, right? And I define this as, even though you have modularity, what is the ease with which you can put these blocks together? And that's where the size of the blocks and the development methodology in terms of how much do you need to know to build one of these blocks, right? They come into picture. And there is quite a bit of work that is out there, which is really useful, interesting, right? And what we are proposing maybe to kind of the next steps of it. That's how I would like to view, right? There's some really good work on micro P4 that happened. What that work is basically, it has like a higher level abstraction on top of P4 that gets translated into P4. So that's the way they have dealt with the composability at the higher scale, right? I mean, you specify at a higher level so that you are able to specify a lot more maybe, and then you translate it down. And the other work that is interesting and very useful is Lyra, one big pipe model. This is like a multi-system composability. You have like multiple nodes. It's not one node, and they're connected. And then you want to look at the whole thing as a single pipeline. And then whatever programs, or you write multiple programs, and then they can be placed across the whole pipe because of the resource constraints and whatnot. So that also covers certain aspects of composability and then certain aspects of disaggregation, right? The whole pipeline is disaggregated and then again composed back, right? There's some modularity. It's all some aspects of that. And the last one, which is the latest and very interesting work, was again, P4 Weaver was built on top of DA pipe. Sorry, Mario, if I'm mispronouncing it, how you named it. So P4 Weaver, this is an insertion-based composability. It talks about the pipeline, and you can insert these modules, and And then this is the latest work, and this is very useful. We can see it's as if as a ecosystem, we are moving forward with each of these models, right? And what we are proposing, hopefully, is the next couple of steps, right? So here is the applet proposal, right? And why are we even saying that we need to do something more, right? Fundamentally, I see it as the existing work does not address the feature interoperability and interactions. That means most of it is like you have your features and then we don't have a formal way of describing those interactions and how they interoperate, either in terms of sequencing sometimes, and then this is coming up more and more on the NIC and smart NICs and IPUs, DPUs as they're becoming powerful. How do you chain them, and do we go by service chaining model, or is there something else? There's a lot of, and having formal specifications there would really help us. The interaction is the other part. When you have multiple features, right, how one feature affects the other feature, right? And then those are the aspects that are not addressed, and I think they become important, and we want to address with Applets, right? And a couple of other things as part of the proposals we have done. Maybe it's not quite part of a proposal. Maybe it's an implementation of an IDE, integrated development environment we have built, and then it kind of addressed few things, and some of them are not non-separable. Your modularity and composability are non-separable. In a way, they get interlinked, right? So there the IDE was looking at, a lot of things happened in software. What can we learn from there that really helps us, right, as we work on hardware pipelines? Can we come up with conventions? Do we have any standard models, like we talked about programming model? Are there any design patterns that are emerging across? Because we are programming with P4 for quite some time, right, and MPL. So can we bring out the design patterns to help the community, right? And can we even come up with frameworks, right? This is like filling up a form, then everyone writing their own form, right? And that really helps us, right? So these are all the things that are addressed as somewhat as part of applet proposal, rest of it as part of the idea, right? So here are the specifics, right? And some of it, you will see it as incremental. So one of the building blocks for the proposal is a base pipeline. And it is designed as a solution to portability. So what we are saying is, if you have two architectures, they are fundamentally different for whatever reason. And then I have seen code that sometimes is boilerplate, has very, platform-specific idiosyncrasies, right? But I could write programs by just putting it inside a macro, hide it, and then just build on top, right? Talking with specific, practical experience. So can this be a solution? Let's say all of us want a SAI pipeline, switch abstraction interface pipeline. Do you, even if hardware architectures are different, we are able to come up with a common SAI across the industry, and more people are adopting it, right? So can we use the same as a solution, right? Can you take the system level services, abstract them, and create well-defined interfaces, create a pipeline, and in your own language, and that is non-negotiable, or that is non-divisible. Let us say the modularity doesn't apply to it. That base pipeline becomes the foundation. And that way you could write two separate pipelines for two separate languages, and architectures gives the same functionality. And that way, in a way, you're not porting the pipeline as such. The base pipelines are non-portable, but anything else you build, like applets, become portable, right? And can we design applets such a way that they become portable, given this as a condition, right? And we'll talk a little more about it later. And the second concept of the proposal is modules, which is basically we are saying applet is the module here. And applet, again, module at what level? Is it at a language construct level, or is it at a higher level? I think here we are saying it is one feature. Each feature, right, when I'm using feature in the way we use typically in a switching and routing area, right? NAT is a feature, access control lists are a feature, tunneling could be a feature, or a specific kind of tunneling is a feature. So all the functionality required for that one feature on top of your layer 2, layer 3 switching that you have is a module, and that is the applet, right? So that is another building block for applet proposal. The third and the most important is that how do you put all of these together to form your final composed pipeline, right? And the specifics of the base pipeline and applets are combined basically, right? So the merge policy is kind of what specifies how these things are combined, right? And it's a policy basically. It's a user based on, because the same applets may be combined in multiple ways, resulting in different kind of semantics. And the typical example is ACL before NAT and after NAT, right? Are different. So you would need to specify what is your policy if you just leave them alone and insert them before or after you get into semantic issues, right? And then there is some overlap with multi-language support also, in terms of if you want multi-language support, can we use a common intermediate representation that reduces the applet into smaller functionality and then is portable from one base pipeline to another base pipeline. In a way, we're reducing the portability problem for porting the whole pipeline to an applet portability. So applet is a smaller feature. So a feature portability is a lesser problem than the full pipeline portability, right? So that's where your merge policy is specifying only the interactions of the applets among themselves and the base pipeline. And base pipeline being a standard kind of reduces scope of that also. So that's where we are helping how applets are put together as well as portability, right? And the last point I want to make before we get into more specifics is that we are proposing multiple merging algorithms and models. The reason for that is that as we build technology, right, there is somebody is building a merchant silicon, programmable ASIC. Somebody else is building a base pipeline, and then we have an ODM trying to put Sonic on it and do something on top, and then maybe there is an OEM might take it and then build some more features on top. It might go to a system integrator and they may integrate differently. So each of them have different levels of knowledge about the internals. They may be operating at different levels, including customers, right? Customers may want to modify something, but they want to operate at a higher level. So having multiple models that kind of are amenable for each of these levels is very useful. The workflow will look like this. As we talked about, I'm going to skip the framework and libraries because that is a big area and that will take a lot of time. In the interest of time, we focus on the main concepts. We talked about having a base pipeline, could be in multiple languages. And then you have applets, which are your functional box. And you have a merge policy that kind of describes how these things are put together. And there is an integrate IDE, which takes all this and builds it into an application. And once that output comes, it's like any of your typical P4 program you could have handwritten. But this is all done automatically. And then you give it to your compiler and whatnot. So that is the workflow of what happens. Now let's look at what kind of merging that can happen, right? So we're proposing three models. One is insertion merge, which is very, very similar. I would say 99% same as what P4 Weaver is discussing, except that we are saying the modular blocks can be slightly different. P4, so this we are saying we could use object-oriented way of designing things, where you are defining an object. And then the knowledge you need to define that is can be limited to that area functionality, and you only bother about what comes in, what goes out. And then somebody else who is building pipelines will take it and insert at the appropriate location in your base pipeline, right? And in this case, your custom, you may have custom merge logic on how this gets inserted, how it interoperates with the base pipeline. It may be already in the base pipeline, or it could be also in different places in the your base pipeline. And maybe the base pipeline takes care of the conditions where the applet is present or not present. It would check for if something metadata exists, then I do, otherwise I don't do something, and things like that, right? It could say if IPv6 header is valid, then do this, else don't do it. So if you are inserting an IPv6 handling as an applet, right? So idea is that your base pipeline, you insert these modules in certain locations, we are done. And then P4 Weaver is kind of proposing same thing, I think, maybe except that there is a control flow that looked more explicit from base pipeline, almost like a go-to statement. You are going to your applet and coming back. I think, and then the way the module is built would be slightly different, I think. The next level of abstract, and this is easy for, let's say, a customer to take and add something, right? And the base pipeline and the number of markers, let's say you have a base pipeline, has functionality. You won't be able to insert anything everywhere because somebody else designed a huge functionality. And so you will be able to insert only in certain locations and only limited functionality. Maybe only that much we may expose to a customer, end customer, right? So it may be a limited set there. And as you go a little deeper, what if you are an OEM who is designing some features and you got something else from the merchant silicon vendor? There you would know more details about the pipelines. Maybe they expose a little more. They gave you a little more markers in the sense that in your base pipeline, certain locations are marked. Hey, this routing lookup table, there is a marker, there is a name to it, and you can do something before that and after that, right? You need these markers so that you can place additional piece of code relative to those markers, right? And that is one, that's a location part. The other part would be, you will be describing in this feature how this feature will interoperate with every other feature, right? So your applet describes the feature itself, but in isolation. You don't need to have the full base pipeline or the full architecture knowledge. You just need to know certain areas only, right? You could have simple features where you are just, what if you're adding 2 numbers? Why should I know about the rest of the things, right? Things like that, right? And the feature merge policy describes how various results of features are put together to arrive at the final result, right? And so essentially it's a policy-driven merging of features. And that in turn will translate to additional piece of code that goes into the pipeline and then does whatever it needs to do, right? And this merging of features need not happen in one shot at the end of the pipeline. It may happen at multiple stages in your pipeline, right? And so that means you may have feature sets. A set of features may be merged using this policy, and then those results are carried forward and additional features may get merged. So in this model, each feature is producing one or many results, and you have a policy describing how these features are combined to arrive at the final feature, right? So that's a feature merge. The field merge takes it to one more level of granularity. From operating at a feature level, it goes to the field level, and I'll let Surendra talk a little more about it later. So there, what happens is essentially you want fine grain, and you really know the whole code. This could be internal, like I said, in the development pipeline of merchant silicon, ODMs, OEMs, system integrator, and customer, right? Each of them have a different role, right? So this is the simplest, this is pictorially showing the insertion merge we talked about. You have a base pipeline, there are a bunch of labels, and only certain number of labels are exposed. The rest of it is not exposed to maintain semantics and a unified semantics that you don't want to mess with. And if you have applets, you will insert, you are on your own. Hopefully, you know why you are inserting, where you are inserting, and the either in the documentation or somewhere it kind of specified. So this is a simpler way to handling composability. The next one we talked about, feature merge, essentially is following an object-oriented methods. Each feature is an object, has input and output fields. Explicitly, certain fields are specified as result fields, and then you can specify feature ordering. They may have dependencies. Certain features may need something else. For example, you need a direction of flow in PNA before you can do something. So if you specify a dependency on the direction, this feature will be placed at an appropriate location. Implicitly, there is an order, and certain order can be explicitly specified, right? And talking about the feature merge policy, here I'm showing you in multiple forms. It can be specified. Imagine you have an access control list form, or just like a code logic, where you are specifying if feature 1 produces a result, and you don't care about feature 2's result, and nth feature produces R9. what would be the final result. That means the moment feature 1 produces a result, make sure that nth feature produces R9 and the final result is R1. So that is right. So in a way, it's an abstract way of specifying how feature results interact and features interact at the feature level, right? And then this can be converted into ACLs, and there are a bunch of algorithms on how to put the features together as well as these access control lists together. So that will be, and this can become an additional code that gets inserted into your pipeline, right? On to field merge, Surendra, do you want to?
Yeah, I would I would explain a little more on the field merge. Venkat talked about various ways of merging. The field merge is the fine grain merge. So here, every applet could be producing many fields. So even with or without applets, it's very natural in a switching pipeline that features produce outputs. And for example, where the packet should be forwarded, should the packet be admitted or dropped. So many table lookups can produce that. And it naturally aligns with applets as well, where the applet may want to change the way the packet is handled, maybe where the packet is going, or whether the packet should be sent to the CPU, or the packet should be dropped, or should have a different rewrite instructions or tunneled or something. So when you make these decisions, how do we know whether this applet 1 or the base pipeline should have the priority? Like who decides what should happen to the packet? And that's where the field merge comes in, where field by field, like it's the allow or edits or the forwarding decisions. You could say, okay, here's the strength of the field. The strength of the field has, some of them have global semantics, but not all of them have the global semantics. Right, so in the Broadcom silicon, there is a priority scheme in the hardware architecture, and as I said, it is called strength. And this construct, the strength construct, is reflected in the NPL as well. So I put a reference to earlier presentation at ACM on the precedence. It has some set of examples as well on why a precedence is important and how that would enable the table dependency resolution. But for applets, when we are talking about the applets, it becomes even more important because that allows you to independently control who is getting the priority. And this priority is not necessarily a static priority. It's not like, okay, PBR, like below I gave an example of, let's say, a policy-based route has a higher priority than a global route. And we have specific routes, it's even higher priority. But this priority could be very dynamic. That says, okay, for this, for example, for these prefixes, I'm going to have applet 1 have a higher priority than PBR. For this other set of prefixes, or for something else matches different set of rules, then maybe I have the VRF specific routes, or the applet 1 or applet 2 takes the precedence. So the precedence needs to be dynamic, because depending on the packet and the subnet or the feature that's enabled, an applet 1 or applet 2 or the base pipeline may have higher strength result to that. So the strength values, so what this says is the strength values could be assigned statically, or more important, strength values need to be able to assign at a table level, like as a result level. So you have a result, you have a field, and along with the field, there is a strength, and the field and the strength is carried through, and then they are resolved at each stage to say, I have an incoming result, and then I have my local result, and then there's a strength for the local result, and then based on that, I can resolve it locally and then feed it forward. And if for some reason you could not make the decision at this particular stage in the pipeline, then you could carry both of them forward, both the strengths forward, and then resolve it later as well. So what this gives you is, more specifically, is like, one is you get a significant reduction in the amount of data that you need to carry through the pipeline. And also it gives you some certain level of independence in writing the applets without having to know every detail. And you could say, okay, here are the places or situations I'm going to be having this confidence level of strength for my results. And for the the applet could assign that, and then they could be resolved in the base pipeline that way. So the example is there. I think like for example, the forwarding is one example. NAT is another example where you could see that the decision to forward or tunnel the packets depends on the features that are being worked on. But so overall, what I would like to carry through here is that the field merge is a powerful concept that allows you to resolve them dynamically along the pipeline, and supporting that in that constructs in the language would help in developing the portable applets. So I think it's.
Thank you, Surendra. So one way I look at it, right, intuitively is that instead of features coming in and you're putting the features together to produce final features, you are looking at it as fields that are flowing through the pipeline, and then every feature is just adding additional results and along with the strengths, and naturally those strength is getting resolved at every stage of the pipeline to produce final results. So it's a very powerful concept. It's dynamic, so you could change the merge logic at runtime. Unlike feature merge, you have fixed interaction. A working with B can produce C, right? Versus here, you could be even changing per ACL line and route. So it's a very powerful concept. At the same time, you don't want to expose this kind of merging to customers. So that's why we talked about you may use different models at different levels of the pipeline. That concludes the presentation.
Thank you, Venkat and Surendra. A very interesting talk and a very interesting topic. I think that's probably one of the biggest topics right now in terms of programmability pipelines, and yeah, I think composability is maybe also the hardest problem, I think. So very interesting presentation. I have a few questions. I mean, in the end, you talked about the difference between field merge and feature merge, and I think there was one of my questions. Can you clarify a bit how you see the exact difference? So as I understand it correctly, feature merge is more like you take the result of a applet and produce a new result, whereas field merge takes parts of the results and merges them individually. Is that a fair statement, or?
Yeah, it is correct. And then there may be something else we need to add to that, right? So idea is the level of granularity at which you want to operate, right? And then, like we said, there's a lot of value in exposing different models as we build composable pipelines, right? Like, so somebody who is a system integrator may want to operate at feature level. They don't want to know every bit and byte and bus, right? Whereas internally, let us say a merchant silicon vendor and an OEM vendor might know more details and they can go down even more, right? So that is one way to do it. Because along with the functionality, you get also complexity. So the field merges can be a little more complex. I want to make a few more comments, right? We also talked, we didn't get into, in the interest of time, about frameworks and conventions and whatnot, right? And these things can really help us as a P4 community, right? With even more adoption on the software and IPUs, DPUs, I see the urgency for that. What do you mean by that? Early days of switching pipelines, we had a fixed set of results. There are only 16 ways you could modify the packet and send the packet. Ultimately, what do we do, right? A switcher router packet comes in, we send it somewhere, and we modify it. There were only 16 ways of doing it. That means we standardized the result to be a 4-bit value, and with additional parameters, of course, right? So imagine that simplistic model for now. Things have got a little more complicated now, but let's go with that. Then what happens? Each feature produces one of the 16 results. And ultimately, you can't send 16. If you have 5 features, you're not putting 5 packets out. You still have to put 1 packet out. One feature says drop, another feature says forward, another says tunnel. What do you do? And you have to specify. That is the merge logic. But the logic operates at the granularity of the feature and that result level, right? So if you standardize the result, it kind of bounds the problem, right? But you can only do certain amount of functionality, certain richness of programs you can do with it. But in reality, when I say 50,000 line programs I've seen, oh, they are like nightmare. Forget for the end user, right? Even for the guys who build, right? I mean, the engineers who build it, it's a nightmare. How do you add? And the more difficulty was when you remove something, a piece of code, the complete monolith got so destabilized that you really have to do complete testing. And then mind you, we have to look at it as hardware. More and more software guys are doing P4 programming, and we're bringing the quality culture of software teams into hardware, right? So having said that, the complexity of feature merge is there. So let us say we want to go to field merge. Each feature has multi-dimensional result. They don't produce one result. Each feature has an opinion about n dimensions. You should send the packet here. You should encrypt it before you send it. Can you truncate the packet? So each feature may have n number of those results producing, and how they all fall together, how they all interact, that can become a huge Cartesian product and can blow up. So you need a simpler model for that. So the typical way we resolve, let's say 4 of us in this call, we have a disagreement. How do we resolve it, right? Is by, for each area, we may have an expertise, right? Okay, if it is access controlist, I am the guru. For routing, Surendra, right? For some other recirculation, it is Jeremias, right? So maybe we have, that way, each of us can, when we have an opinion, we could have a local policy of merging, or we could also have a priority or some kind of a strength associated with our results. And there are many models overlay there. So that's what is the whole crux of field merge, right? But because you are operating at the field level, naturally features are giving their opinions, and the opinions are getting resolved at every stage, continuously at each stage of the pipeline. In the end, you have n final opinions of what needs to happen to the packet. Do you tunnel it? Do you encrypt it? Do you forward it? Where do you send? All that is there, and you do it, and then we go. So that is that's a way to look at it.
Thank you. That answers the question, and I think it kind of leads naturally to a follow-up question, maybe a bigger question in this context, and that's, you mentioned the fields and the applets, but where does the common semantics come from, right? You talked about earlier that you assume some kind of fundamental pipeline. Would it mean that if I write an applet, it's specific to the pipeline and takes over the expected fields and the semantics of these fields from the pipeline? Or how do you imagine this fundamental question? Or
So maybe one way we were looking at it was, I think we may be just jumping over the hard problem, right? Sometimes not solving the hard problem, just leaving it boxed, it is a solution, by the way, right? So one way to look at that was, before we go to applet, the base pipeline itself, right? We said we will have a SI pipeline. It'll exist. It's getting more and more adopted. We will have a PSA pipeline. We may have a base pipeline, base pipeline.npl, right? There is a certain pipeline. So maybe they become universal. There won't be too many of them, there'll be few. And each of those, and hopefully over a period with wider adoption, they get reduced, honestly, the more programmability there. So you will end up with 1, 2, 3, or 4 of these base pipelines, and they don't try to change them. I mean, we cannot swim against that, right? Because these are huge ecosystems around it. Then the second question is, okay, if you have 3 such pipelines, let us say, can I write a single applet and make it work on all of them? What we found is that a good subset of them can work. Some very simple applets, but you need to design it upfront. You need to have conventions from the beginning on how to write. We need some frameworks. Then you can even do multiple languages. You could take a P4 language applet and put it on an NPL pipeline. If, like, for example, I'm giving an extreme case just to create simplicity. If you're just adding 2 numbers, or you are changing an IP address into some other IP address, how does the language matter? How does your architecture matter? You specify that, if you give me an IP address, I will transform it into another IP address in an interesting way. And you like this interesting applet that I have. And you as a pipeline, this composable pipeline designer, come up with a policy merge on where you are going to use it. It doesn't matter what language it is. So we have reduced the problem from the portability, composability, interoperability between languages, architectures into an applet size problem, which makes it easy. It's like a bite-sized thing you can choose. Surendra, you may have a, go ahead.
So I want to throw in another example as well. What we are seeing is that many of our customers, they're not actually trying to innovate a lot on the forwarding itself. They're trying to innovate a lot on the telemetry. So like, what is instrumentation? They want to get interesting information and concise in a concise manner, send it out somewhere, make some decision somewhere, and they get the result back. So especially for telemetry, what I find is because you're not actually modifying it, there's not as much chance for collisions. You're more like you're gleaning the information out. And you could imagine an applet that does certain type of telemetry that could easily portable across the SI or PICO or NPL. So I just want to throw in that telemetry is a very important aspect that's going on, and that is it's another plane to the forwarding plane, and you could have applets or innovation happening there.
Yeah, sorry for a long answer, but I want to just add one more very interesting point, which is useful for the community, right? Is that we have standard conventions in SI. There are another standard conventions in other pipelines, and we can translate the IDEs, the software tools can use. Even simple things like coding conventions, right? There was a very interesting proposal from Alan Lowe. I really loved his proposal on how to name every variable. There are only TCP and UDP headers can't we agree on, right? Which made a lot of sense. But I quickly found out, I'm sure Alan also found out, that it could, there's 5 opinions about it. That means, can a tool come in and just change A_B into like a camel case, right? So the IDEs can really do quite a bit of these translations between languages and conventions and solve so many of these problems. And then that is one. And the other one, like I already mentioned, by reducing the scope and the knowledge needed to build applets from the beginning, if we define the modularity in a certain way, we can really make progress, right? I'm really excited about how practical this is to drive it over a period of time in the community.
Yeah, I agree that it makes a lot of sense to focus on specific problems and limit the scope. I think that's the main, it seems like a very good approach to actually make progress, right? I mean, I don't think, especially the semantics problem, how do you name variables and what kind of features do you have? You kind of solve it in a general case. So yeah, I think that makes a lot of sense. What you just touched on, that you have the applets and they have a very limited scope. That makes sense to me as well. But now coming back to the thing that you, I think, said in the beginning of your talk, there's the general problem of different hardware platforms have different feature sets. So you mentioned earlier, you might want to change a packet, but you might not be able to do it at a specific point in time or in the point of the pipeline. Do you have thoughts on how to handle that in applets? Would you propose to have a certain constraints put on what you can do in a specific applet? So basically having different types for different parts of the pipeline. Have you any thoughts on that topic?
Yeah, I can add some, and maybe Surendra might have opinions, right? So see, there are certain things you cannot do. I don't think we can do some magic and make them happen, right? But in terms of mapping one programming model to another, right? So I look at it as 2 pieces. One is the programming model, which is slightly more than syntactic sugar. Syntactic sugar is just different ways of expressing it, but the semantics are practically same. They become a little easier. I'm not saying it's easy. I've tried translating between languages and whatnot multiple times. You can do more or less 99%. So that's a first level that can be done. What we're talking about is the next level where even the semantics change. And there we need to take 2 branches. If the semantic, the implementation semantics can be worked around. That means you cannot modify packet in ingress pipeline. You can do memory versus compute how do you say, trade-off, use a little more bus bandwidth, take more results and change the packets on the egress and things like that. So there are So you may have to tease the, tease out this problem into smaller problems and separate out the semantics into, sub-semantics, like is it implementation semantics, is it the location, and then solving each one is the right way. And there'll be some things like, okay, you don't have an extern that cannot, that can encrypt, then you cannot do anything, right? But majority of the other things can be solved. That is one. The other, hope it's not too vague what I said, but I want to make one point though. Even simplest things like checksum calculation and checksum computation and replacement, each model specifies it to happen only in one location. Honestly, I don't think they intend it that way. It can be moved around, they'll still be fine in the model. So we may over a period reach these base pipelines that are not targeted to any one of the platforms, but are more optimal way of specification that is easy to map to system, right? So, and that will come out only when we reduce the number of base pipelines, start doing applets, and we want to learn, right? The best practices also will evolve over a period. We want to adopt even applets. I would recommend to be adopted in stages so that we learn as we go and then it evolves, right? We don't want to jump on. I hope that answers some aspects.
Just want to add to that is that I hope people will start adapting this sooner than later, because relatively, even though P4 and NPL have been around for a few years, it's relatively young actually. I've seen in my previous plays, the hardware always has limitations on how many features you can put in. There's always customer requirements keep coming in, right? And then over time, this becomes really messy to maintain and manage. Even though like if a fresh brand new hardware, you're writing a code, you have original programmers, it goes well. But after 5 years, 6 years, 7 years, you'll keep adding it and the maintenance becomes really a problem. So I agree with you. I think there will be some limitations going with the Applets, like you cannot do everything because of the differences in the platforms, but there is still a broad set of interesting problems that you could solve using the common baseline features that are available. So, and there's enough number of interesting features that you could write as applets that if you take that approach, the maintenance and over the long term, it becomes much better for the industry. Because I have seen in the hardware, like the hardware is somewhat different from software in the sense that there's finite resources, finite capabilities. The understanding of it is important, and you need more people to be working on it over time.
Yeah, I think that makes sense. Yeah, I agree. Maybe before my last question, to put it in my own words and to see if you agree on that, it sounds like you're suggesting to basically have a limited set of customizability using, or modularity using applets. And the first step would be basically to define these pipelines and to provide some flexibility in the pipelines, but not the full set of flexibility, right? So you're basically focusing on specific aspects. As you mentioned earlier, you see patterns with some customers that they have specific ideas, for example, telemetry, but they don't have the wish to fundamentally change the whole pipeline behavior. So the way to go would be to focus on a specific area, define an abstraction for that, a pipeline, and then add this modularity features using applets. Would that be a statement that you agree to? Just to try to sum it up from my view.
Yeah, that makes sense.
Okay, I think that's a great approach. So my final question would be, you said it's a suggestion, but is there any work done in this direction so far? What's the status of the project?
Yeah, so this is something that we built at OpenNets, and I'm not part of OpenNets now, but I'm hoping they'll open source it. Somebody will help them get it to open source. There's some very interesting work there, and then hope to put a demo of those IDs out, because a lot of this, some of it is convention, some of it is design patterns, some of it is frameworks, and that will start. It's not necessarily that we are reducing the scope of what you can do. It is just that constraining the full freedom and still do what you want to do, right? I mean, you have 10 ways of doing it. What if I give you only 2 so that we converge? That's the way I would rephrase your last thing, maybe, right? Thinking back. And I think for that, we need tools, right? As humans, changing every TCP underscore type to TCP, right, is very painful. So the tools does quite a bit of that. And so that the tools are implemented, they are out there. So if it comes back and if it gets contributed to the community in some way, then we can start adopting them. Yeah, I mean, in terms of status, yes, some of this is implemented, it is there.
That's really fantastic to hear. And yeah, open source would be amazing if we could have that at some point in time. So I'm looking forward to yeah, potentially future contribution in that area. Great. Thank you very much for giving the talk and the very interesting discussion.
Thank you.
Thank you.